devices, semiconductor electronics materials devices, and simple circuits. Okay, so this is standard 12 CBSE physics previous year's questions answers. Okay, so let's resume our discussion. First question. Write 3 characteristic features in photoelectric effect that cannot be explained on the basis of wave theory. We know that there are 2 theories. One is particle theory, other is wave theory. Okay, but can be explained using the Einstein equation. So Einstein equation is quantum theory, correct? So let's explain the 3 characteristic features of photoelectric effect. First, light emitted from the metal surface only when incident light is above a particular frequency. Okay, so suppose this is the metal surface. Whatever be the intensity of light, if it meets a particular frequency called threshold frequency, if that frequency of light or above that frequency light incident, then only that photoelectrons emitted from the surface. Okay, this threshold frequency below which no photoelectrons are emitted cannot be explained by wave theory. So only quantum theory of Einstein explains this reason. This is one part. Threshold frequency based photoelectrons emission cannot be explained by normal wave theory. Okay. Second, photoelectric current is proportional to the intensity of incident light for a given metal and frequency. Okay. So if you increase after the threshold frequency given to the metal surface, if we increase the intensity, then the photoelectric current, the number of electrons emitted increases and the photoelectric current also increases. Okay. Third, maximum kinetic energy of photons is dependent on the wavelength or frequency of the incident light above threshold frequency. This maximum kinetic energy is independent of intensity of the incident light. Normal wave theory says if more intense light is incident, then that intensity is more means energy is more. There should be emission of photoelectrons, but no, it is independent of intensity. Okay, it depends on the frequency of the incident light, or you can say the wavelength of the incident light. Correct? It doesn't depend on the intensity. So these 3 phenomena can only be explained by the quantum theory of Einstein. So take the screenshot. Next question. Write the function of 3 segments of transistor. Draw circuit diagram for studying the input and output characteristics of PN transistor in common emitter configuration. Using circuit, explain how input-output characteristics are obtained. Okay, so we'll explain the 3 segments of transistor. First is the emitter, second is base, and then collector. So what is emitter does? It supplies the majority carriers in the transistors. Suppose if it is NPN transistor, then N means electron is the majority charge carriers. If it is PNP transistor, then the holes are the majority charge carriers. So moderately sized and heavily doped. So it supplies the heavily doped means impurity of other atoms when mixed with the naturally occurring semiconductor, then it is called doping, correct? Second is base. It controls the flow of charge carriers, very thin and lightly doped. So the ratio of impurity atoms is less here. So base of transistor separates the emitter and collector. Okay. So this is suppose the base, one is collector, other is emitter. Collector. it collects the majority charge carrier supplied by the emitter. So emitter supplies, base controls, okay, and the collector collects. So size is more than the emitter and moderately doped. So these are the three basic segments of transistors. Okay. So draw the second part of this question says that draw the circuit diagram for studying the input and output characteristics. Okay. So this is a transistor that we have taken here, correct? So the IC means collector current, correct? So this is the, just take it, IE is the emitter current, okay? So the voltage between the collector and emitter, this is the voltage. VC means the voltage across the collector and emitter. VBE means this voltage is the applied between the base and the emitter, okay? So this is the input voltage applied. So when the input voltage is applied through a resistor is also given, here is a resistance given, and here this is the load across which the output is obtained, okay? So this is the collector circuit, collector voltage. So here we get the output. So see input characteristic. Now see here the input voltage is low. If you see the amplitude of input, and what is the output? Output is intensified, correct? Amplified, correct? So Vi means input voltage. If you put very low input, we get amplified output, correct? So this is diagram for the circuit diagram for studying the input and output characteristics of NPN transistor. Okay, this transistor symbolizes NPN transistor, correct? So now, what is input characteristic? Let us take. We have taken base current in milliampere along the y-axis, and the base emitter current, correct? So the base emitter voltage is applied along the x-axis. Now if we go on increasing this base emitter voltage, we find that for a particular, when the collector emitter voltage is 0, then on applying the base emitter voltage, if you increase it, then the base current increases. See, this is the increasing base current. Similarly, when the collector emitter voltage is greater than 2 volt, okay, and if we increase the base emitter voltage, then my base current increases like this. So on increasing base emitter voltage, my base current increases, correct? So this is explained for different collector emitter voltage. Two graphs we have shown in this input characteristic. So let us explain. So for input characteristic, the base current versus base emitter voltage is plotted while collector base voltage is kept constant. Okay. For collector voltage 0, collector emitter voltage 0, this is the graph. For collector emitter voltage when constant at greater than 2 volt, this is the graph. Okay. So the collector emitter voltage is kept in the range of 3 to 20 volt. Input characteristic for various values of collector emitter voltage from 0 to greater than 2 volt gives almost the same curves as shown in the above graph. Okay. Now this is the input characteristic. Now let us study the output characteristic of transistor. So means here in the x-axis we have plotted the collector emitter voltage. Okay, and in the y-axis we have taken the collector current in milliampere, correct? Now the output characteristic is obtained by varying the collector current with collector emitter voltage. So if you go on increasing collector emitter voltage, okay, you will get different values of collector current. So keeping the base current constant, if you keep the base current say 300 microampere 250 microampere, 200 microampere. So by increasing the collector emitter voltage, we find that the collector current increases, correct? So different curves are obtained for different values of base current. Okay. So this is the output characteristic. Take the screenshot. This is an important question for you. Studying the input and output characteristics and circuit diagram of a transistor. Next question. Mita's father was driving her to a school. At the traffic signal, she noticed that each traffic light was made of many tiny small lights instead of single bulb. When Mita asked this question to her father, he explained the reason for this. So answer the following question based on the above information. Where were the values displayed by Mita and her father? What were the values displayed? What answer did Mita's father give? And what are the small lights in traffic signals called, and how do these operate? Okay. So this is 4 marks question. First, Mita shown her curiosity. Her father exhibited awareness about the traffic equipment, also presence of mind and scientific temperament. Advantage of LED, light emitting diode. Okay, so which consumes less energy. Nowadays you know that to reduce the electricity bill, we are replacing the normal tungsten based bulb by LEDs. So it consumes less energy in comparison to a large incandescent lamp. Okay. Also LED has higher reliability, so it doesn't get fused very easily. Otherwise this tungsten filament based bulb, so this type of bulb get fused often, correct, and it consumes more energy, more electricity bill will come, but we are replacing this tungsten based filament based bulb by LEDs, correct? So this is the advantage. Now these tiny lights are LED light emitting diode. Actually PN junction semiconductor operated at forward biased mode, okay, based on principle of de-excitation of electrons. So we can apply a PN junction or semiconductor either in the reverse bias mode or forward bias. In forward bias we get the output, maximum output. So these LEDs are basically what it is. These are the PN junction, okay, and this is applied in the forward bias. Okay. So take the screenshot. Now distinguish between intrinsic and extrinsic semiconductor. Naturally occurring semiconductor like silicon, germanium, these are called the intrinsic semiconductor. They are not giving that much output. That is why we are putting some impurity atoms by process of doping and making it extrinsic semiconductor. Okay, so let's see the difference. Intrinsic semiconductors are naturally occurring semiconductors found in nature, okay, like germanium, silicon. Now, number of negative charge carrier electron is same in as the number of holes in intrinsic semiconductor. Extrinsic semiconductor means impurity atoms are added. This process is called doping with trivalent like aluminium or pentavalent like phosphorus to naturally occurring semiconductor. Now once the process of doping takes place, then this intrinsic semiconductor becomes the extrinsic semiconductor. Number of negative charge carrier and holes are not same. Hence, based on the doping atom, we get donor type or acceptor type, P type or N type semiconductor. So this is the difference. 1 plus 1 marks for two distinguishing features. We have 2 marks allocated. Okay, so you can take the screenshot. Next question. With what consideration in view photodiode is fabricated? State its working with the help of a suitable diagram, even though the current in the forward bias is known to be more than in the reverse bias. Yet the photodiode works in reverse bias. What is the reason? So half plus 1 and half plus half. Okay. So total 2 and 3 marks question. 2015 this question was asked. So during the photodiode fabrication, our prime objective is to allow light to incident on the photodiode, hence transparent window provision is met. Okay. Okay. So let's see this diagram first. So we have this is a this one side is P type, and other side is N type. So here the majority charge carriers are electrons, here the majority charge carriers are holes, correct? And this is the interface between P type and N type. This is the depletion region, correct? So what happens, because of this holes, some of the electrons gets transmitted from the N type to P type, crosses this barrier and comes here. Okay, these electrons are found here. These are the negatively charged electrons, which are the majority charge carriers here in the N type. They comes and crosses and resides here. Similarly, some of the holes resides and comes here, correct? So this is the depletion region. Okay, so this is acceptor ion, holes, and this is donor ion, means electrons, correct? So now this is figure 1. Now forward bias means P type with positive, N type with negative. This is called forward biasing. And what is reverse bias? Just opposite polarity, P type with the negative terminal, N type with the positive terminal. So when a PN junction is connected in such a way that the P type means the accepted type, or the holes are the majority charge carriers, is connected with the negative terminal of the battery, then it is and the donor type means electrons are the majority charge carriers are connected with the positive, then such biasing, such connecting with the voltage terminal is called the reverse biasing. Okay, so these 3 figures are now clear, correct? Okay. So working. How does this PN junction works in forward and reverse bias condition? Let's see. So when the photodiode is illuminated with photons, if the energy of the incident photon is greater than the energy gap of the semiconductor, then the electron hole pairs are generated. Okay, so this is the depletion region. So when PN junction is forward biased, the majority charge carriers flow towards the junction. The width of the depletion layer decreases as shown in the figure 2. So means forward biasing means now what? These are the electrons. These electrons and this is connected with the positive terminals. So these electrons will come here, correct? So rush of electrons will happen. Okay. Now when PN junction is reverse biased, means this is negative, here the electrons are there and they are the donor type, correct? So here also negative, so this will not get attracted. However, because of this already that electrons which jumped to this side, okay, diffused electrons, there will be a small current, correct? So in PN junction, is reverse bias, the majority charge carriers flow away from the junction because electrons will not be attracted towards it, correct? However, few electrons which are already jumped in this, okay, and came here, when a positive is applied here, then it will move towards this, correct? So the width of the depletion layer increases, means this will provide a barrier to this flow, correct? So as shown in the figure 3, correct? So the depletion width, if you see the depletion region here, when it is not connected with the neither forward bias nor reverse bias, here the depletion width is less, but here in reverse bias the depletion region we have shown that it is increased in reverse bias condition. So reason, in reverse bias mode the fractional changes in the current is due to the minority charge carrier and is more significant than the changes due to the majority charge carrier current. Hence, it is easier to observe the change in the current with the change in intensity during the reverse biasing. Hence, reverse bias is preferred. Okay. So, this is the explanation to this question, and you can take the screenshot. This reverse biasing mode of operating is very important part, correct? So Jenner diode is normally operated in reverse bias mode. We'll study that part also now. Next question. Draw circuit diagram of a transistor amplifier in common emitter configuration. Define the term input resistance, current amplification factor. How are these determined using typical input and output characteristics? Okay, so let's do it. This is the circuit diagram in common emitter configuration. Okay, so let's see the circuit diagram. This is collector current, this is the emitter current, this is the voltage applied between the base and the emitter. This is base, this is emitter, base, emitter, collector, correct? So it is common emitter. So emitter is common, correct? So let's see. And this is the load across which we take the output. Okay. So this is the collector voltage EC, and this is the VCE, means the output voltage obtained across the collector and emitter, correct? So circuit diagram is very easy, and here is the input voltage. Input voltage is less. See the amplitude, correct? This is input voltage, and this is the output voltage. Okay, so you see the amplification amplitude increased, okay, where the output is obtained. So if you give this much input here, this is the input, you get, this is the output obtained. So this is amplified. So now circuit diagram is explained. This is the input voltage, this is the output voltage. VO is the output voltage, correct? Now we have to define certain terms. Okay, so what is input resistance? Input resistance is ratio of, resistance is V is equal to IR. So we will follow this formula. So resistance is voltage divided by current. So which voltage? Voltage applied between the base and emitter. So the change in the voltage between the base emitter divided by the base current when the collector emitted voltage is constant, then this ratio is called the input resistance. So input resistance is nothing but the ratio of base collector voltage divided by change in base collector voltage to the change in base current for a particular collector emitter voltage, for a constant collector emitter voltage, correct? What is current amplification factor? We call it beta, correct? So what is current amplification factor? It is the, when for a fixed collector emitter voltage, the ratio of collector change in collector current to the change in base current. Okay, so this ratio, the ratio of collector to base current, is called the current amplification factor. Obviously, for amplified circuit, the collector current will be more than the base current, so this will result the current amplification factor more than 1. There will not be any unit because it is the ratio of current, collector current to base current. Okay, so let's see the diagram here, the graph here, correct? So this is IO, okay, and here for a particular collector emitter voltage, okay, for a fixed collector emitter voltage, we have seen the current. Okay, so let's see. The value of input resistance is determined from the slope, means base current to the base emitter voltage. Okay, so if you take the slope of it, particular place, if you draw a slope, correct, so this slope will give the for a particular segment of this. Suppose here you draw a slope, so this is what, this is the base current, this y-axis is the change in the base current. Okay, so input resistance we have to find out, right? Correct. So slope is tan theta. Okay, and what is this? So the slope of IB versus the VBE. Okay, VBE means the base emitter voltage, correct? Okay. Okay, so this is base emitter voltage. Okay, so okay, so this graph, from the slope of this graph, we find that the at a constant collector emitter voltage, when the collector emitter voltage is 10 volt, is kept constant, then this ratio we have found, we can find out through this slope, correct? Okay. Now the value of current amplification factor is obtained from the slope of the collector current versus the collector emitter voltage plot using different values of IB. For a particular base current, this is the collector emitter voltage versus this is the collector current, correct? So if we go on increasing the collector emitter voltage, we find that it increases up to certain, the collector current increases, but then it becomes constant. Okay, so for different base currents, when the collector emitter voltage is increased, the collector current initially increases and then becomes saturated, then becomes constant, correct? So this gives me the value of current amplification factor by the slope of this collector current versus the collector emitter voltage, correct? Okay, so let's take the screenshot. Next question. Write the truth table for the combination of gates shown. Name the gate used. Okay, truth table is input to output. Okay, what are the different inputs that we have given in the form of binary format, 1-0 format, to the output, okay, obtained. So this table, this different permutation combination table, is called truth table. Now this is the circuit given. Okay, now this is A and B, these are the input. Then A is taken to this is the AND gate, this symbolizes AND gate, this symbolizes OR gate, correct? So what OR gate does? OR gate adds. What AND gate does? AND gates, if suppose A and B are the two input to the AND gate. Okay, so it multiplies. A into B is the output. If A, B is the input, then this AND gate, this D type of symbol is the symbol of AND gate, which multiplies the two input signal. And what is OR gate? OR gate adds. Suppose if A and B is the input, then output is what? A plus B. So this is a combination of OR gate and AND gate. But how it operates? So first of all, this OR gate adds A plus B. So what is Y? It is A plus B. And what is the, this is the Y input goes A plus B, and then A, and these two are getting multiplied here. It is A into A plus B, correct? Now, let us take first of all this value, that is the input signal in this to this AND gate. So for two input we have taken this combination 0 0 1 1 0 1 0 1. Okay, for 0 plus 0, this is Y dash is what? A plus B. So 0 plus 0 is 0, binary format. 0 plus 1 is 1, 1 plus 1. If either of the input signal is true, then the output is true. If both are false, both are 0, both are minimum, then only the output is low, output is 0. So 1 plus 0 is 1, 1 plus 1 is also 1. If both are high, then the output is high. Okay, so one of the input is, if 1, then the output is 1, correct? So now here the input to the AND gate is A and Y dash, correct? So now 0 plus 0, it will multiply. So 0 plus 0 into 0, Y dash is what? Y dash is 0, first combination, 0 into 0. So 0 into 0 is 0 dot 0 is 0, correct? So 0 into 1 is of course 0. 1 into 1 is 1, and 1 into 1 is 1. Okay, so the output is such that if one of them is, if both are low or one of them is low, correct, then the output is low. If A and Y dash, if you see this combination, let's understand this characteristic. If either of the input, so input is A and Y dash, these are the two input to S, correct? So if either of this is 0, then the output is 0. If both are 1, then only output is 1, correct? So now if A or B, any one signal is 1, then Y dash will be 1. This is the OR gate. OR gate is A plus B. In S, if S means AND gate, multiplies. If either A or Y dash is 0, then Y will be 0 AND gate. So this is the truth table. For all permutation combination, this gives you the input versus output result. So in the above diagram, R is OR gate, S is AND gate, correct? Now, take this as a screenshot. Next question. Identify logic gates marked P and Q in the given circuit. Write the truth table for the combination. So this is AND, but there is this symbol says it is NAND. Means whatever multiplies A into B, this becomes not. This becomes negative, nullified. Okay. So AB not is the output of NAND gate. Okay. And here if B comes, to B will be this, correct? And this is OR gate. Means A dot B not, okay, and B. These two are input for this Q, and this is a OR gate. Q is OR gate. This simply adds B plus AB not. So let first, what is the AB not? this input to the OR gate. So let us take this combination. So if 0 and 0, okay, let us take one more column here to explain what is x. Okay, so let us take this. Okay, so this is suppose y dash, my y dash. Okay, so let us see what is the output from P. So 0 into 0. So 0 into 0 is 0, but since it is a NAND gate, so its not means 1. So it is 1. For 0 0 combination, y dash is 1 for this combination. Okay, one of the input is 1. Now this is 1 and this is 0. It adds up. So now if 0 and 1 gets add up, 0 plus 1. So output is 1. Now for the second combination, 1 into 0. What will be the y dash? Y dash is 1 into 0 multiplied by naught. 1 into 0 is 0. So 0 naught means 1. Now here it comes 1, here it comes 0, correct? So 1 plus 0 is 1, correct? The output will be, so 1 into 0 naught is 0, naught means 1, and 1 plus 1, 1 plus 0 is 1. Now what is y dash? 0 into 1 naught. 0 into 1 is 0, its naught is 1. So and 1 plus 1, 1 plus 1 is nothing. 1, if 2 high are added, then the output is high, 1. Now a 1 into 1, what is y dash? Y dash for this last combination, 1 into 1 naught. So 1 into 1 is 1, its naught is 0. So it is 0. Now 1 plus 0 is 1. Okay. So this is for whatever be the input of this combination, output is all the time it is 1 only. Correct? So this is the truth table explained. So that's all for today. We'll finish it up tomorrow. In the next video, if possible today only, we'll finish this entire electronics part, electronic devices physics previous year's question, okay, in my next video. Thank you very much.